This lecture is about bada's collection namespace. In the lecture, I'll briefly introduce collections and what they are. I'll discuss a few common interfaces and enumerators used by collection classes, along with some helper classes. I'm also going to discuss a few classes related to common data structures, such as lists, maps, stacks, and queues. The collection namespace contains classes and interfaces for various collections. A collection means an aggregation of similar objects. Imagine a stamp book with stamps from different countries. Each stamp has its own features, but in the end, they all form a collection of stamps. The point of this example is that the collection refers to the container rather than its contents. As application programmers, we come across many collections in our daily life, such as arrays, lists, stacks, and so on. We often refer to them interchangeably as data structures. Therefore, we can say that a collection binds multiple objects into a single unit. The classes provided in the collection namespace are reusable and extendable. For programmer convenience, both template-based and non-template-based variants of classes are provided. Okay, let's understand what a collection is. A collection, sometimes called a container, is simply an object that groups multiple elements into a single unit. Collections are used to store, retrieve, and manipulate aggregate data. In bada, a collection refers to a group aggregation of items of the same data type. It provides ready-to-use common data structures, along with generic APIs for common operations, such as accessing, searching, adding, deleting, modifying, etc. The classes provided are reusable and extensible. Corresponding to common data structures and their functionalities, the classes in the collection namespace can be categorized as lists, maps, multiple maps, stacks, and queues. In the following slides, I'll discuss these classes in more detail. Now, let me explain what interfaces and enumerators refer to in bada. I'm also going to explain a few important interfaces and enumerator classes in the collection namespace. An interface refers to a class where all the functions are defined as virtual functions. An interface can be regarded as a set of functions necessary for classes that perform a specific function. For example, the iList interface is a class that consists of functions that list classes must commonly have, regardless of the implementation method or data type. Enumerators are special kinds of interfaces that can iterate or traverse over a collection class instance. Enumerators cannot modify or alter the collection object and remain valid for as long as the collection object is unchanged. The collection class provides various interfaces, including the iCollection, iEnumerator, iList, iMap, and iMultimap interfaces. I'll discuss more about these interface classes in the coming slides. The most important interfaces in the collection namespace are iCollection and iEnumerator. iCollection provides the getCount and getEnumeratorN methods. The getCount method returns the number of items in the collection, and the getEnumeratorN method returns the enumerator interface. iEnumerator is the enumerator of the collection, and it's used to get the items in the collection in sequence. The enumerator provides the getCurrent method to get the object at the current point. The moveNext method moves the point to the next object, and the reset method moves the pointer to the first item. The iList interface is the basic interface of all list classes. The iList interface provides the functions to add or remove objects, to get items at a specific index, and to find an item in the list. The actual implementation of the iList interface is through the ArrayList class and the LinkedList class. Additionally, an iCompare interface needs to be defined to sort the objects in the list. I'll discuss the iCompare class in more detail later. The IMap interface abstracts a collection of key-value pairs. An IMap contains unique keys, and each key maps to a single value. Both the key and value cannot be a null reference. The IMap interface provides functions to add or remove objects with the specified key, to find whether a key or value exists, and to modify the value against a key. The actual implementation of the IMap interface is the HashMap class. The iMultimap interface abstracts a collection of key and multi-value pairs. An iMultimap contains unique keys, and each key maps to multiple values. Both key and values cannot be a null reference. The iMultimap interface provides methods to add or remove objects with the specified key, to find the existence of a key or value, and to modify the value against a key. The actual implementation of the iMultimap interface is the multi-hash map class. For a hash map and multi-hash map, a different enumerator from the existing enumerator is required. This enumerator is called IMap enumerator. The IMap enumerator class provides functions to get the key or value of the current point. If you call the getCurrent method to get the object of the current point, the method returns the map entry object. The map entry object contains the key and value pair. Besides this class, there is also the bidirectional enumerator class that enables enumeration both backwards and forwards. In the next few slides, I'll discuss a few important helper classes. All the concrete classes in the collection namespace use these helper classes to provide functionalities such as sorting and generating hash codes. The iHashCode provider interface provides the hash code for a specific type of object. All classes which need hash calculations should implement this interface's getHashCode method. The iCompare interface provides the functions to compare objects, allowing programmers to decide on the greater, smaller, or equal relation among two different objects of the same data type. Bada provides a few comparers for some of the commonly used data types, such as double comparer, float comparer, string comparer, and so on. You can find more comparers in the developer guide. In general, a list refers to an ordered collection or sequence of homogeneous data. In the next few slides, I'll discuss the list classes provided in Bada and some example code to demonstrate how to use these classes. Array list and linked list are collections of objects that can be accessed by an index. These are dynamic lists, and the capacity can be increased or decreased dynamically. Currently, items in the list can only be heap variables because list methods only perform shallow copy operations. They don't copy the elements. Only the pointers to the elements are copied. Now, let's take a look at how we can use an array list using an example. As I mentioned before, the items in a list are created in the heap memory. You can see in the example code snippet how to create an array list instance, how to add some elements to it, and how to use the getAt method to get the object as a specified index. And finally, how to remove some elements from the list using remove and removeAt. You can also insert an object at a specific index using insertAt. In line 1, we are instantiating the array list object list. In line 2, we construct the list with the default capacity. In lines 4 and 5, we're adding two integer objects with values 1 and 2 respectively, resulting with the list holding the object's addresses with values 1 and 2. In line 7, we retrieve the object at index 1. In line 8, we insert one more integer object with value 4, resulting in the list holding the object's addresses with values 1, 4, and 2. In line 11, we remove and delete the object with value 1, resulting in the list holding the object's addresses with values 4 and 2. In line 14, we remove and delete the object at index 1, resulting in the list holding the object's addresses with value 4. In the last two lines, we're adding two integer objects with values 1 and 3, resulting in the list holding the object's addresses with values 4, 1, and 3. In this example, I'll explain how to sort the items of an integer array. As I mentioned earlier, to sort a list, you need to use the comparer interface. In the course of an integer list, you can create the pre-implemented integer comparer class instance and sort the list using this. The IEnumerator interface accesses the objects in the collection in sequence. This example also demonstrates how to access the items in the array list on the screen sequentially using the enumerator. The same functionality can also be achieved using the for loop. In this example, we're using the same array list instance created in our previous example list that has the objects with values 4, 1, 3 at indexes 1, 2, and 3 respectively. In line 2, we have the integer comparer instance. In line 3, I'm sorting the list, resulting in the list having objects with values 1, 3, 4 at indexes 1, 2, and 3 respectively. In line 7, the getEnumeratorN method returns an enumerator to traverse all the list elements. In line 8, I'm traversing through each element within a while loop and printing values. In line 14, I'm directly accessing the list objects at indexes 1, 2, and 3 inside a for loop. In the next few slides, I'll discuss the maps and multi-map data structures provided in bada. The classes that are created by actually implementing a map and multi-map are the hash map and multi-hash map classes. These classes initially have a capacity to hold 16 items and arrange objects by assigning hash codes to the keys. HashMap is a collection different from a list, as it's used to store key-value pairs. Therefore, to add an object, you have to specify both the key and the value. You can also delete an object corresponding to the specified key. Additionally, functions to check if there's an object with the specified key in a collection and to get the object corresponding to the key are also provided. Besides these functions, more functions are provided to get all the keys in the hash map, to get all the values, to get the enumerator used for the hash map only, and to change the value for a specified key. While there's only one value for a key in a hash map, the multi-hash map class can be used when there can be more than one value for a key. Therefore, methods to check if there's a specified key and value pair, to identify how many values there are for a specified key, and to change a specified value for a specified key are provided. Most importantly, a hash map and multi-hash map must have unique keys. This example shows how to use a hash map. First, I prepared 3 keys, name, age, and phone as strings, and I added a key name, and a string John pair, a key age, and an integer 15 pair, and a key phone, and a phone number string pair to the map. Then, to get the value of age from the map, I called the getValue function of the map, passing the string age. Then I cast the value to the integer pointer to get the value as an integer. This example also shows how a value corresponding to a specified key can be deleted from the map. In lines 1 and 2, the hash map instance is created and constructed with a default capacity and load factor. In lines 8, 9, 10, we're adding key and value pairs to the hash map. In line 12, we are retrieving the value corresponding to the age key. In line 14, we are removing and deleting the element with the key age. This example shows how to access or traverse through the element of the map in sequence using the IMAP enumerator. Although this example is almost the same as that of the enumerator, the difference is that this example gets each key and value pair from the enumerator by calling the getKey and getValue methods and printing them. In line 1, we're retrieving the map enumerator from the hash map instance. Then, inside the while loop, we are traversing each element and retrieving the corresponding key and value. In the last line, we're removing all the elements from the hash map and releasing the memory allocated to each element. In the coming slides, I'll discuss the most common data structures, stack and queue. A stack provides basic stack functions, such as the push, pop, and peep functions, and a queue provides functions such as the enqueue, dequeue, and peek methods. Basically, since the stack and queue classes are created by implementing the iCollection class, methods to get the enumerator and count using the getEnumerator method are provided. Additionally, the contain method is also provided to check if there's a specified object, even though the method is not in the iCollection class. In summary, in this lecture, I introduced interfaces. Bada interfaces are classes starting with I and have virtual functions. The ArrayList and LinkedList classes are created by implementing the iList interface class. Each of the classes supports sorting using the iCompare interface. In Bada, all the collection objects can get an item using the enumerator class. A hash map is a collection type class to save a key and value pair. Finally, the OSP collection namespace also provides the stack and queue classes.